Welcome to part one of your human body notes, where we're focusing on the digestive system. Our learning targets for this lesson are for you to explain the function of each and every organ in the digestive system and be able to pick them out on a diagram. And you'll also learn what an enzyme is and what they do during digestion. All right, we mentioned having to know what an enzyme was, and there's two big enzymes that we want you to be familiar with when we're talking about the digestive system. Basically, an enzyme is any molecule that speeds up the rate of a chemical reaction. So you have enzymes all over your body doing all different things, but they're very specific for one particular kind of substance. And in our example here, this is the enzyme, and it's very specific for a molecule that looks like this, okay? And in this reaction, they're showing you a molecule that's being put together. So we have, for instance, two atoms getting joined together, but in digestion, really the reverse would be true. You have a molecule that's getting taken apart to make smaller molecules, but they work the same way. It's very specific. Only this atom or this molecule will fit into this enzyme's shape. And so when that happens, it makes this whole process happen faster. And this just happens over and over again. So more of these atoms would come in here, bind together, and then be joined. It's just like a little molecule producing factory, or in the case of digestion, a little factory that breaks down molecules. So the first enzyme we want you to be familiar with is called amylase. Amylase is found in your saliva, so sometimes you'll hear it called salivary amylase, and it is very specific. The molecule that it works on is starch. So starch is a carbohydrate. It's basically a big long chain of sugar molecules. So when you eat something that has starch in it, like bread, bread's full of starch, when you start mixing that with your saliva in your mouth, it immediately starts to break down starch. If you ate something with protein or fat, a different kind of nutrient, it would be mixed in the saliva, but amylase would not do any work on it. So again, it's just another way to speed up the digestion process. It starts right away in the mouth. So by the way, again, starches are foods like bread, pasta, potatoes, and rice. The second enzyme to be familiar with is pepsin. Pepsin is found in the stomach, and it breaks complex proteins into less complex proteins. So proteins are things found in meats and eggs, and some nuts and beans, but it's specifically designed for proteins, and we first find it in the stomach. So when you eat something with protein in it, this enzyme is going to go to work on it when that food gets to the stomach. Okay. So, enzymes are all over your body, responsible for many chemical reactions, not just the ones in digestion. You've got this picture in your notes that shows the main ones that we use in our bodies and where you find those working. So just know that. Now you'll move into the inside of your packet, which is basically going over the structures in your digestive system and the functions. And they are also noted here on the diagram. You should be able to identify these from a diagram. So make sure you're kind of looking over here as you're writing. All right, first on the list is the mouth. So your mouth's job is to begin both mechanical digestion, which is with your teeth and chewing and your tongue, and chemical digestion, which is your saliva. So glands in your mouth produce saliva, your salivary glands, and inside that saliva is this enzyme amylase, which breaks down starch. But most of your saliva is just water and a little bit of mucus to make the food slippery enough to swallow.
The journey of food through the digestive system starts at one end of the digestive tract, the mouth, the gateway to the digestive system. Inside the mouth, teeth cut and grind food into smaller pieces. This breaking up of food is called mechanical digestion. As you chew, glands pump saliva into your mouth. The saliva moistens the food and makes it easier to swallow. Saliva also contains amylase, an enzyme. Different kinds of enzymes help digestion by breaking up large molecules into smaller ones. Amylase acts on large molecules of starch, a kind of carbohydrate. Amylase breaks up starch into smaller molecules of sugar. This kind of digestion is called chemical digestion. Chemical digestion is different from the mechanical digestion that occurs when we chew food. To see the difference between mechanical digestion and chemical digestion, put some food, like a piece of meat, in a blender. A blender chops food up into smaller pieces. This is similar to the mechanical digestion that goes on when we chew. You can see how chemical digestion works by putting a piece of meat into a substance called gastric juice, which contains several enzymes. The meat doesn't break up into different pieces, but in less than an hour, it changes its color and texture. The enzymes in gastric juice caused protein molecules in the meat to break down into smaller molecules. After food has been chewed, you swallow it, and it begins its journey through the rest of the digestive system.
Dear Tim and Moby, can you tell me about teeth? Signed, Mangy Poo. Hey, sure thing, Mangy Poo. Your teeth are the first stop for the food we eat. They're like little tools in your mouth that cut, crush, and grip food so that it can be digested. Humans have 20 teeth when they're born, although it takes a while for them to erupt or come out from underneath the gums. At around age 6, these so-called baby or milk teeth start to get pushed out by adult teeth. It might hurt a little, but it's completely normal. They usually just pop out after getting really wiggly. If you're lucky, the tooth fairy might come at that point. Remind me to tell you about her later. Anyway, people have 32 permanent teeth, 16 on the top jaw and 16 on the bottom. Let's take a closer look. The front incisor teeth bite and chop off pieces of food that can fit into your mouth. Your pointed canine teeth beside the incisors are there to help tear the food apart. Your premolars, or bicuspids, are used for crushing and chewing. Then the larger, flatter molars squash food so that it can mix with saliva to make a gooey mass that's easy to swallow. The molars farthest back in your mouth are often called wisdom teeth. Wisdom teeth usually take a long time to erupt, well into adulthood for many people, and in some people, they just won't come out at all. Good call, Moby. Let's see what a tooth would look like if we sawed one in half. The hard outer layer of your teeth is called the enamel. In fact, it's the hardest substance in your body. Beneath the enamel is a softer layer called dentin. The dentin supports the enamel and gives the tooth its shape. The roots connect the teeth to the jawbone in the same way that a tree's roots connect it to the ground. A hard substance called cementum covers the roots and anchors our teeth in place. At the center of your teeth is a soft mass called the pulp. The pulp contains blood vessels and sensitive nerves. Your teeth are really strong, but they can decay if old food in your mouth builds up and starts to grow bacteria. Big deposits of bacteria called plaque release acids that can eat a cavity in the enamel and expose the sensitive parts of your teeth. This can be painful. Ah! Cavities have to be drilled out to remove the decayed enamel and then filled with a hard sealant. This is something to avoid. So take good care of your teeth and keep them clean by flossing and brushing. Oh, that reminds me, I have to floss. Oh no. Stop it! Stop it! You're not helping me!
Once you swallow your food, it goes down a tube called the esophagus. ESO was a word the honors kids had to study, and this part, PHAG, means food. So sometimes we kind of nickname the esophagus your food tube. So it's basically made of a muscle, and it connects your mouth to your stomach, and it squeezes food. So that squeezing motion is called peristalsis. And here you can see on the diagram how that works. It's kind of a squeezing and then pushing out. So as the food travels down, it experiences that squeezing motion, peristalsis. This happens in other parts of the digestive system as well. There's also a very small flap of tissue at the back of your throat when you swallow food to try to prevent it from going down your windpipe. You actually have two tubes, the esophagus back here and the food tube the air tube right in front of it, which we will learn more about. That's called the trachea. But you don't want food in here because that would equal choking. Okay, so the epiglottis, that little piece of tissue, is to try to prevent food from going the wrong direction. Next on your list is the stomach. Your stomach is a muscular bag where food becomes liquefied, and once it does that, we call it chyme. Think of like the consistency of milkshake. And if you have thrown up, like we see happens to this astronaut, you know what that feels like. It's partially digested, partially broken down food. And also going on in the stomach secretes acid and the enzyme pepsin, which breaks down proteins into smaller particles of protein. Your muscles in your stomach also move back and forth, squeezing the food. We call that peristalsis. That is partially responsible for breaking food down mechanically. Okay, so once food has been in your stomach, it enters your small intestine. And the beginning part of your small intestine, the first few feet, is where food continues to get broken down. There is digestive juices from the liver and the pancreas that get added into the chyme, which further break the food down. There's other enzymes, there's other juices that turn off the action of your stomach acid. And the first few meters or feet of your small intestine are for continuing to break down your food. But your small intestine is a very long tube, 7 meters long in adults. And so as the food coils around through all of these links of coil, the next step is where food is being absorbed. And this is where food molecules, the nutrients that you're eating, are getting put into your bloodstream. And you'll find on the inside of this tube are these structures called villi, which are these little finger-like projections. This is what they look like with an electron microscope. And basically, they increase the surface area so that inside this tube, instead of it just being a smooth surface, you have all these little tiny projections that allow there to be a lot more space to absorb the nutrients into. this would also help speed up the rate of digestion because a lot more nutrients can get into the bloodstream that way. So this is really the second phase of your digestive process, where whatever food you've taken in, you've now broken down. And as you can see in this picture, these villi are lined with these basically capillaries. They're blood vessels. We'll talk about why they're red and blue there in a little bit. But that is going to allow those food nutrients to enter the bloodstream, and the blood will carry them where they need to go. The large intestine is also known as your colon. Here's a picture from a colonoscopy. We all have that to look forward to. Usually they recommend you have a colonoscopy by the time you turn 50, which is basically sticking a camera up here and taking a look and making sure there's no cancerous polyps. So easy preventative way to check that. But the main job of your large intestine is to absorb water, okay? Because you do use a lot of water in the digestive process, and you don't want that to go to waste. You want to recycle that water. So as food is passing into this large intestine, it's kind of like a little vacuum cleaner, and it just sucks up all the water and puts that back into the body. And whatever doesn't get absorbed or hasn't passed through to the bloodstream is going to become more and more solid as it moves through the large intestine. So we would consider our large intestine a homeostasis organ, or an organ that helps with homeostasis, because it's helping us maintain that fluid balance in our body. The other thing about it, it is called large because the size of the tube, the diameter of the tube is wider than the small intestine. It's not as long as the small intestine. And the other little trivia thing to know is that this is where our appendix is located. So our appendix is this little offshoot of the large intestine right here. And, you know, you can live without it. We don't think it has a function. It may have had a digestive function millions of years ago when humans had a different diet than we do today. But sometimes this can get infected. People, you know, maybe start having pain in their abdomen, and this thing has become swollen with bacteria or other things. And the threat is that you don't want it to burst. If it bursts, that stuff would go into your bloodstream, and we don't want that to happen. So often, if they suspect you're having appendicitis, they will take that out. So at the end of your large intestine is sort of a holding tank for waste, and that's called the rectum. And basically you have it's very muscular. It's a bag that stores the waste that is accumulating in your body. And, you know, when you start to feel that there is waste there, your body will signal you to go to the restroom. And that brings us to literally the end, which is the opening of the of the digestive system at the other end of the body, which we call the anus. And that's where waste leaves the body. This is not my dog, by the way, but I do have two dogs, and so I am used to this view. Now, there are some important organs that food does not pass through, but are still included in the digestive system because they contribute important functions. And those three are the liver, the gallbladder, and the pancreas. So let's talk about those. We also have the liver. Your liver is probably your largest digestive organ. It's very large. It has 4 different lobes, which you can't really see in this picture. Kind of sits underneath your rib cage there. It's reddish in color. And its job is to filter the blood, particularly toxins that you take into your body, like alcohol or other drugs or medication. The liver filters those out. It also produces bile, which is a greenish liquid, and the bile gets stored in the gallbladder. So you may have seen bile if you've ever thrown up on an empty stomach. It's kind of that greenish fluid that you'll see. But bile's job is to break down fat into smaller particles. It's not an enzyme, but it's a chemical that helps break fat down. So again, bile stored in the gallbladder, and the gallbladder kind of looks like a little pea-shaped organ that is up underneath the liver. In this picture, you can't see it. It would sit sort of behind the liver in this picture. There we can see a better picture of it. So the gallbladder is that small sac that stores bile. By the way, if you've ever had someone in your family who has had gallstones, that's basically crystallized bile that gets stuck in this tube, the tube that takes the bile from the liver to the small intestine. And of course, like any other stones that are stuck in your body, those are pretty painful and usually need to be removed by surgery. So first is the pancreas. Your pancreas basically does many things. It secretes some hormones, it makes enzymes that break down carbohydrates, and it has a fluid that it secretes that turns off stomach acid, because that acid in the stomach is very strong, and you don't want that getting into the small intestine because it can damage the small intestine. If you've ever had heartburn, you know that that's what's happening with heartburn, is some of your small acid from your stomach is splashing back up into your esophagus, and it feels like a burning sensation. It's near your chest or in your chest, so that's where it gets its name, heartburn, but it really has nothing to do with your heart. So again, food does not pass through the pancreas, but it is an important digestive organ, and it is yellowish in color, so good to know.
Hey, these are really good. My compliments to the chef. Dear Tim and Moby, how do we digest food? From Sam. Oh, why thank you. Digestion is about breaking apart the food we eat so that our bodies can use the food's nutrients. Food is broken up in two ways, mechanical digestion and chemical digestion. Mechanical digestion is the physical breaking apart of food. Chemical digestion is when chemicals called enzymes break food into molecules that your body can absorb. Both types of digestion occur in our mouths. Chewing mechanically breaks food apart, while an enzyme in your spit called salivary amylase breaks down carbohydrates. When food you eat becomes a soft, gooey mass, your tongue pushes it to the opening of your esophagus at the back of your mouth. The esophagus squeezes the food down into the stomach. Inside your stomach, food is churned and mixed with enzymes and other digestive juices, including hydrochloric acid. These chemicals break down proteins and fats. A lining of mucus protects your stomach from the acid. After about 4 hours in your stomach, food is the consistency of a thick milkshake, and we call it chyme. Chyme moves into the small intestine, which is actually not so small. It's about 7 meters long. The small intestine is where most of the nutrients from food are absorbed. In the first part of the small intestine, called the duodenum, digestive juices from the liver and pancreas join the breakdown mix. They turn the chyme into a soup of molecules small enough to be absorbed into your bloodstream. Well, there are these tiny finger-like things called villi lining the inside of the small intestine. Cells on the surface of the villi absorb nutrients from chyme as it flows by. When chyme gets to the large intestine, it's thin and watery. The large intestine is actually way shorter than the small intestine, but because it's a lot wider, it's called large. Sometimes it's called the colon. The large intestine sucks most of the water out of digested chyme in a process called absorption. This step is important because recovering that water keeps you from getting dehydrated. Once most of the water is gone, solid waste is moved to the last part of the large intestine, the rectum. When enough waste piles up there, you're ready to go to the bathroom, and the digestive process is complete. The whole digestion process can take up to 2 or 3 days. Ooh. I think I ate too many pancakes.